can share when you have something. Also, what we do today is going to help with tomorrow's common assessment, some of those questions that will be on there from Unit 2. Oops, Cody, I sent that to the wrong person. All right, so we just had some people join us. You guys, we are going to be focusing on Unit 2 today. Some of the concepts from the Unit 2 test that we're going to see on our common assessment tomorrow. And then also this session, what we go over will help with your Unit 2 test corrections. All right, has anyone found the midline yet? Yes, Cody, you're right. So we can determine the midline and the amplitude using the minimum and the maximum. Okay. That sounds good. So at the top, this is 110. At the bottom, this is -90. So we could subtract those. Find the difference. Let me see if I can verify. There we go. I hope that's better for you. Okay, so you said let's find the difference. So 110 minus -90 is 200. If we subtract these, we get 200. Yep, and that is also helpful. So if we find the difference in the max and min is 200, then half of that is 100. And what is that value? Is that the midline or the amplitude? Right. So the amplitude is going to be 100. So subtracting helps us find that. Now, if we add them, which is how I usually start, if we add -90 and 110, and then divide by 2, remember that's going to give us the middle. We're averaging those two numbers to find the middle. What is this, you guys? 110 minus 90 is 20. And 20 divided by 2 is 10. How did I do? Okay, so we just found the midline is 10. Somewhere in here. Okay, so if you think back to that modeling assignment that you did a couple weeks ago on, what was that, an async day? Same thing. You have the maximum temperature, the minimum temperature, and you can use those to find the middle by averaging them, add them together, divide by 2. You can also find the amplitude. All right, so probably the most missed question on the test had to do with modeling. Let's go ahead and go over this problem to help us with modeling. And then this should help you with test corrections for number, was it number 9? Number 10. This should help with number 10. Okay, so we're going to graph this, we're going to come up with an equation, and then we're going to use the equation to answer the questions at the bottom. So a Ferris wheel is 50 meters in diameter. It rotates once every 3 minutes. What does that sound like? The center axle of the wheel is 30 meters from the ground. The test corrections. Nope, so there's not a second attempt. The way that the test corrections work is when you submit those for the questions you missed, you earn back half the points that you missed. So let's say you made a 50, then that means you missed 50 points and you could earn back 25 of them. So your 50 could turn into a 75. So it's kind of like extra credit, bonus points you're getting back on your original. Okay, so if it rotates once every 3 minutes, that sounds like the period. How often it's going to repeat, and the center of the wheel is 30 meters above the ground. That sounds like the height in the middle, and that's going to be the midline. Let's go ahead and put that over here on the graph. The midline's at 30. Okay, what is the height at the top of the wheel and at the bottom of the wheel? We should be able to use the diameter to get that. So when you're in the middle of the Ferris wheel, you're 30 meters above the ground. What about at the top of the Ferris wheel? Yep, so the radius is 25. So then we can use that to find the height at the top and the height at the bottom. So 30 plus 25 is 55. 30 minus 25 is 5. Okay, so that hopefully makes sense. All right, so then over here on the graph, that means, and by the way, the graph is modeling the height over time. Okay, so the maximum height reached is 55, and the minimum height is 5. Okay, so go ahead and set up that part of the graph. Okay, what else? It says, assume the wheel starts rotating when the passenger's at the bottom. So usually whenever you get on a Ferris wheel, you get on from the bottom. That's why these always usually start at the bottom. So our first point is going to be right here. Okay. Again, how long is it going to take to get back to that same height? 3 minutes. So after 3 minutes, good, Devin, we're back at the bottom of the wheel. And that is the period of the function. Okay, so we know it's going to take half the time to get to the top. So half of 3 is 1.5. And so here's our first cycle. And then it would just repeat, right? After another 3 minutes, and then another 3 minutes, and it repeats. Okay, let's come up with the equation. What is the midline and what is the amplitude? Also, which type of equation would you write for this one? The midline is 30. Okay, so in our equation, that'll be what we add at the end. That's D. The amplitude is 25. 55 minus 30, 30 minus 5. Okay, also, you guys remember the amplitude is going to correspond to the radius. From the middle to the top on the Ferris wheel, from the middle to the top on the graph. Radius, amplitude. All right, for B, remember there's a formula for B that we need to know. 2 pi divided by the period. So 2 pi divided by 3. That's B. We're not going to do a phase shift. We're just going to start right here. at the y-axis, which type of equation should we write for this one? If it starts at the bottom. Sine, cosine, negative cosine, Vanessa, good. Yes, okay, definitely not sine, because sine starts on the midline. Okay, since it starts at the bottom, that's cosine with a reflection. Usually we know cosine starts at the top, it's flipped, so it's negative cosine. All right, here is our equation. The reflection. B goes right here. Don't forget your variable. There's X, and then our midline. Okay, so on the test, you had to do this. You had to get to this point to be able to answer the questions. Okay, you come up with an equation to model it. And once you have the equation, now we can use it to figure out what is the height after 10 minutes. Okay, one option is to plug in 10 for X. Another option is to graph it on Desmos. And I am going to do that option. We can do either or. Remember the Tarzan problem? I know that you do. We used Desmos to help us answer those questions, looking at the graph. And then plus 30. I think this was it, you guys. You might have to kind of zoom in or out. Oh my, oh my. Okay, see how the graph is going 10, 20, 30, 40, and I'm getting all these little tight. I could spread it out. How about we just go from up to 10? Yep, we're going to plug in a 10 for X. Good. And we might be able to see it. It's just kind of, oh, okay. So after 10 minutes, the height is 42.5 meters. So really, we don't have to. I was going to suggest changing the scale over here in the settings. Right now, we're going up to 107. Let's just go up to 10 and go down to negative 10. And then it's not quite so much. All right, so there, what was it? 47, 42.5. And for the next part, and this is 42.5 meters. Part B, how long after the ride starts does it take the passenger to reach a height of 48 meters? So we can plug in 48 for y equals 48, or use Desmos. Y equals 48, because height is the y value. And how long after it starts? So it starts at 0, and right here is the first time it's going to reach 48 meters. Okay, now it's going to keep going around and around and around. So it's going to hit 48 meters several times. But the question said how long after it starts. So we're looking for this first time it reaches 48 meters. Let's round this to 1.1. It's going to take 1.1 minutes. 1.1 minutes. All right, how is this? Does this help? You think that's going to help you with number 10 on the test? Any questions here I can help you clear up? All right, and don't you think Desmos is going to be helpful? Pretty helpful. Okay, from here, I'm going to kind of open it up. So this is what everyone has in Canvas today. So there are some problems for today that go over Unit 2 concepts, but they're the Unit 2 concepts that you're going to see on Common Assessment 3 tomorrow. So we're going to work on those. And so I have those here. And they're also in the module. Let me launch. Actually, hold on a second, you guys. Let me just grab the document. I have it right here. So it's up to you if you want to print it or do it in Cami or just write them down on paper. but we're going to start taking a look at some of these. Now, I don't know that we'll get to all of them. So that's why I'm saying we can kind of pick and choose which ones you think you need the most. And then whatever ones we don't get to, you're welcome to join this afternoon in the open office. And we can go over more of them. ELD problems. Okay. So we can take a look at these. Okay. I just did the wrong one. So it starts out with arc length. And then number 5, I know you remember the one on the test about the clock. So number 5 is similar to that one. We could go over that one. Oh, go over the clock one. 6 and 7 are both about finding the period of a graph and finding the coefficient for B. And then the last one, number 8, is about those domain restrictions. So let me know if you have a preference. I think we might want to start with the clock. And that is going to help you with your test corrections also. But you tell me. Okay, so I think I'll pick for us. I'm going to pick number 3. And then number 5. We're going to start with those 2, and then you can choose from there. So for the first 4, arc length, there is a formula that we can use for these. Remember, S equals R times theta. Okay, so we can multiply the radius of the circle by the angle measure, but that angle measure does need to be in radians. Okay, so for number 3, it looks like the radius is 12. It looks like we actually know the arc length is 47.1 inches. So what we're looking for is the angle measure. Going a little backwards here. Okay, so we could take the same equation and go ahead and plug in 47.1 for S. Plug in 12 for the radius. And that'll be 12 times theta. Okay, so we just need to divide by 12. And notice this is going to be the approximate angle measure. So approximately 3.9 radians. Okay, we can't come up with the exact because the arc length itself wasn't exact. It was approximate. Okay, also, if you'd rather, we could rearrange this formula. If we solve for theta, theta is equal to S divided by R. Arc length divided by radius, which is basically what we just did. Arc length divided by radius. And that gives you radians. Okay, so far, any questions here? Okay, so you can use this one formula to solve for any of the 3. You could find the arc length, you could solve for radius, you could solve for the angle measure. All right, let's go to the clock one, number 5. You guys remember this on the test? It's not the exact same one, but it's similar. Okay, the radius of a clock is 7 inches. What is the length of the arc on the outer edge of the clock between 12 and 5? All right, we know the radius. Let's come up with the angle to use. So we're looking for the length of this arc right here. How do we find theta? So we're working with a circle. It's divided into equal parts. So what is the angle measure between like 12 and 1? Or 1 and 2? Yep. So since the clock is divided into 12 equal parts and a circle is 360 degrees, then between each hour, the angle measure is 30 degrees. Okay. Well, from 12 to 5, we're going to multiply that by 5 to find this angle measure. So that's 150. Okay, so now we have the angle measure. What do we need to do before we can use the formula? Exactly. Yes. Okay, so it's got to be in radians. So let's convert. We multiply by pi over 180. Okay, this one's also on your unit circle. Let's see, I'm gonna divide by 10. So now it's 15 over 18. I could divide by 3 and it's 5 pi over 6. And now we can calculate. So the arc length is going to be the radius times 5 pi over 6. Okay, so that's 35 pi over 6. There's the exact answer. 35 times pi divided by 6. That's approximately 18.3. Okay, theta, by the way, that was 5 pi over 6. Okay, so this is one way to do this one, is using that formula S equals R times theta. Okay. It is also possible to calculate the circumference because we have the radius. So we could find all the way around the circle, find the circumference, and then take 5/12 of the circumference. Since the circle is divided into 12 parts, and this is 5/6 of the circle. All right, what do you think? Does this help with that question? Number 1 on the test. Any questions? No, I don't see any questions. You're gonna ask me if you have one. Okay, all right, you guys. Okay, let's do one of these. Okay, we're doing good. We are doing great. Determine the period of each graph. All right, that first one. Go ahead. What is the period? We can find it from the equation. We are going to use the 16 to calculate the period. It is pi over 8. Okay, so the period is not directly in the equation. This 16 right here is, let's see, that's a horizontal compression, right? It's going to take the period 2 pi and compress it by a factor of 1/16. So to calculate the period, we use this formula, 2 pi divided by b. All right, go ahead and take a look at the next one. So the period of this graph is pi over 8. It's going to repeat every pi over 8 units. Okay, this one looks a little different because this time the coefficient has a pi in it. That's okay. Pi is a number. Pi over 20 is a coefficient for a variable. Anybody think they have it? I think that's it. Let's see. So we have 2 pi, and we're dividing by pi over 20. So we multiply by the reciprocal. Those pi's are just going to cancel out, and we get 40 for the period. So you know how sometimes the graphs are labeled on the x-axis with exact radians, and then sometimes they're measured with just regular or labeled with regular numbers? So this one would just be regular numbers. Okay, cancel, cancel. And then one more. I think so. I think that's it. Okay, let's see. So the coefficient, we know it's not just 5, right? Since 5 is on the bottom, it's a 1 over 5. It's a 1/5. So then it's 2 pi divided by 1/5. Just like the last one, we're going to keep change flip. 2 pi times 5. So see, this time the pi doesn't cancel. So the period is going to be 10 pi. Okay, so I wanted to give you a little variety there. Sometimes the coefficient has pi in it and the period doesn't. Sometimes the period has a pi in it and the coefficient doesn't. Okay, so one or the other is going to have a pi in it. All right. We're going to do the same thing, but now rather than looking at an equation, let's look at graphs. Okay, so before we can find B, we got to find the period, which, by the way, this is similar to number 8 on your test. You had to find B looking at a graph, and you had to type in the answer as a whole number or a decimal. All right, so we start by finding the period. What's the period for the blue graph? I hope you can read those tiny numbers. Yep, 6 pi. So we're looking for the length of one cycle. A good place to look for this one is from this maximum to this maximum. Okay, so the period is 6 pi, and so now we can easily find B. Go ahead. Remember the formula. Good, Vanessa. 1/3. 2 pi divided by the period. 2 pi divided by 6 pi. And that equals 1/3. Yay. Not so bad, right? All right, this next one, find the period of this graph. This graph is counting by 0.25. Two point oh. Yep. You guys see it? So again, I would probably use this one and this one. Okay, those are great to use. You can't always use them because sometimes there may or may not be a label there, like we can't tell what that point is. But if I can use the maximums, then that is a good choice. Negative 0.7 to positive 1.25. The difference in those is 2. Okay, so 1.25 plus 0.75, 2.0. All right, go ahead and find B. Pi. Yes, 2 pi divided by 2. And so B, oops, is pi. All right, I feel like this is helping. Is this good? Pretty good, pretty good. We're going to be able to finish all of these today. Oh, I guess we skipped 1 and 2 and 4. Yay. Okay, the last part, the domain restrictions. Let's see, on the test, this was it the last question, number 12? Yes. Okay. We're gonna find an interval of the domain of these functions where the function is invertible. Okay, so there's really just 2 criteria for that. We're looking for an interval of the domain where it passes a horizontal line test, but also it goes from a min to a max, or from a max to a min. We got to include all the values in the range so that when we go to find an inverse value, we'll have all the values included from the graph. Okay, so horizontal line test and from bottom to top. Okay, so notice I did something a little different here and I didn't give you the graph. Okay, but that's not a big deal because Desmos. So let's graph this first one. Do sine 1/4 x. All right. Now, if you want, you can change your window. Okay, see how it's very flat, very squished. And again, it's counting on the y-axis, it's 20, 40, 60. That's just too much. Let's go smaller. Let's go to, what's this? Let's go to like 10 right here, or 5. So on the y-axis, I'm gonna go -5 to +5. Okay, there we go. And you've already got it. All right. So as long as we pick out something that goes from a max to a min, or a min to a max, either way, that should do it. So you said 0.5 to -0.5. Oh, you're saying for y, excuse me, for the scale. Okay. So let's see, we could go from this point right there to this one right here. We could do this interval. Okay, so if we look at those x values, we got to hover. This one is -2 pi. This one is +2 pi. So -2 pi to 2 pi is one option. We could also go from here to here. Right? This passes the horizontal line test and it includes all the values from -2 to 2. So that would be 2 pi to 6 pi. Okay, so because we're giving, for this function, we're giving an interval of the domain of this function. So use x coordinates. And so these answers can vary. All right, go ahead and try the next one. Okay, and when you find an interval, go ahead and share it with us. Let's see if we can come up with more than one option. Okay, there are two different options. Let's check those. All right, I think I graphed the right equation. Does that look right? Where's the function? Where? What? Oh, equal sign. All right. Woo. Okay, so 1.5, 1.25 looks good. To this one down here, 2.25. Yep, Vanessa, that works. Good. That's this interval from, and you want to go from a consecutive min to max, right? I wouldn't want to go like from this one way over here to this one. Got to be consecutive. Negative 2.75, right? Where is that? Where is negative 2.75? Right here? Where is it? There it is. Negative 2.75 to this one right here. Negative. So I think, Cody, would it go from negative 2.75 right here to negative 1.75 right there? All right. Any questions here? One last thing about these is something like from here to here. This interval, a lot of times you'll see these as a choice. This interval passes the horizontal line test, but it leaves out the bottom half of the graph. So that's not a good interval to use. It's got to go all the way from bottom to top or top to bottom. Gotcha. Okay, you guys. Well, then from here, work on those Unit 2 test corrections. They are due a week from Monday. So you have some time to work on those and get those turned in. Again, to earn back half points on your test, bonus points on your test. This afternoon, there's an open office from 1 to 2. So if there's anything you need, come on by. What else? Catch up on some lessons today. So Monday's lesson, we started simplifying and verifying trig identities. Go back through some of that. You could take a look at the guided practice that's in the module from Monday or the video. And I will see you guys tomorrow. I actually won't be here tomorrow afternoon or Friday. So if I have you in the morning, I'll see you tomorrow morning. If not, you'll have a sub tomorrow afternoon, and then I'll leave work for you guys to do on Friday. All right, you guys, I hope this helped. Let me know if there's anything else you need. I can stick around for a minute. Have a great day. Bye, everybody. You're welcome. You too.